Great. Okay. So, ladies and gentlemen, we're going to first have a blunt intervention here, and then a targeted intervention. Okay? Now, the blunt intervention is going to be very stylized. We're basically going to see the effects of positing faster treatment of people. So we shorten the duration of infection. Okay? And we can undertake this in two ways. One way is a particularly simple way that we've actually explored. We could take the baseline, let's say with birth, copy, paste. It'll be pasted in as baseline with birth 1. And I'm going to say halved, H-A-L-V-E-D, duration of infection with birth. And I'm going to change the infection to be from 10 days to 5 days. This is a particularly simplistic characterization, but it's going to serve my purpose for illustrating sort of one way to capture an intervention type effect. We postulate, starting at the initial time, we've changed the situation, so we treat people, we locate and treat people quickly, and we get them in for treatment. Therefore, we have a faster identification of the person for treatment, therefore a lower time infectious. So I'm going to run this, and if we run this out, we'll find, okay, the infection dies out, and people, basically, the infection does not propagate in the population. That's okay. We postulate, okay, this stylized intervention affects things. Similarly, we could say lower by 20% or what have you. I think it's pretty clear. We could postulate that. That's pretty old hat for you folks. You've seen it before. And it doesn't really address the question, once the infection is established, once the ecology has gotten going, how does it change things? So what I'd like to show you is actually, I'm going to set up something that is sometimes called the brutal button. Okay? The brutal button. Alas, Wade is not here. Neither Wade nor Winslow are here, because they both appreciate the historic context. Okay, we're going to set up a brutal button. Okay? We're going to go to the baseline with birth. Well, actually, we just go to main. It's going to run from any scenario. And I'm going to put in something the like of which I don't believe you've ever seen before in your own models. It's going to be something that actually presages how we as computer scientists build user interfaces. How we build the thing sometimes derided as a snout. Okay? It's snout making. Okay? So I'll teach you a bit of snout making. And together we will build the brutal button. Okay. So, ladies and gentlemen, I'd like you to go to the palette, and I'd like to go with you to a place we've never seen before. A place whose very icon connotes the button part, although not the brutality. Okay? Where within this smorgasbord of different options do we see something that has a button-like appearance? Where is it? Yeah, it's this controls. Let's go to controls. Now, computer scientists are Maybe I don't need to say. Computer scientists are sometimes a little bit weird. And we have this habit of giving names to things which are not obvious. So we'll talk about root, for example, and the root is sort of the top of a hierarchy. It's the root of a tree that goes downwards, which you might think is a strange concept. But here, controls doesn't mean like control of an infectious disease. It means little widgets that you put in that can that allow the user to interact with the system. That's called a control, okay? And you'll notice in the palette, in the controls area, there's a thing called button. We're going to use that, okay? And we're going to put it up here. Let's say put it up above this thing that says how the distance scale that's in place. And there's a button. And we're going to name this button. Well, you could name it brutal button. I'll call it intervention button. Okay? We'll get to the brutality reference in a bit. Okay? And the label here will be undertake intervention! Exclamation point. And I'd like you to make it a distended button so you can see the fulsomeness of its name. So I labeled it. Now you can see the button actually has a label on it. It says undertake intervention. So by pressing that button, we're going to be able to undertake an intervention. Are you okay with that? Okay. Now the intervention we're going to undertake is just as simple as what we've just seen. But we're going to be able to undertake it in a different way. And I'd ask you to help me appreciate why that is. But particularly, all we're going to do is we're going to halve the duration of infection. Okay? When we press that button, when we engage in brutal button pushing, we're going to change the duration of infection. Okay? Okay, ladies and gentlemen, we're going to say this dot mean duration of infection. We're going to halve it. And we can do this by dividing it by 2. We could say mean duration of infection equals mean duration of infection divided by 2.0. That would work. But there's actually a more pithy way to say it in Java. You could say divided by equals this. That actually means, hey, set it to its current value divided by that. Okay? You can use whichever one you prefer. If you prefer to use this, you could do so. Otherwise, you could use this. There's some advantages to having this divide equal to, because then we don't have to write it twice. It's very clear once you know this syntax, it's very clear, we're just dividing it by 2. The same thing by 2. That's all. Okay. Ladies and gentlemen, we could press it twice. What would happen? Suppose it was the value initially of 10. Suppose we were to press, or say 20. Suppose you were to press it once. What would it go to? 10. Go from 20 to 10, divided by 2. Then we were to press it again. What would it go to? 5. 10 divided by 2. Okay, we'll be able to frob it. And by engaging in said frobbing behavior, we'll be able to actually lower it to a lower value yet. Okay? Ladies and gentlemen, I would like you to try building. The TAs stand ready, or more precisely, they sit ready this time. Okay? Who needs TA help? Okay. Okay? Lacking that, I would invite you to run baseline with birth. was beeping when we came in the morning, just to let you know.
Okay,
Yeah.
thank you.
Yeah. Okay? So we're going to run this, ladies and gentlemen. And is anything different happening than before right now? No, because we haven't changed this value. This is the same basic model picture we saw before. It goes up, but let's let the infection circulate. This is baseline with birth we're running. Let's let it circulate. Let's let it sort of get to a place where it's really well mixed. Okay. Okay. Great. It's proceeding upwards here, and eventually what's going to happen based on before? This initial cohort is going to die out. This initial cohort is a distinctive cohort, scarred by the first propagation of infection at the initial time, where it was overwhelmingly susceptible. Okay, so ladies and gentlemen, it's being pushed out, and soon enough that's going to disappear through the depredations of death. Okay, you could see they're winnowing in number, and soon they'll be but a cherished memory. There we are. Ladies and gentlemen, shall we press the brutal button? Ladies and gentlemen, hearing no objections, I'm going to press it on mine. Watch this. Okay. So now what's happened is I've actually changed the value of that parameter. Unfortunately, that parameter is it's not obvious what its name is, but it's one of these guys here. It's mean duration of infection. I guessed right. It was 2 down. Now it's changed to 5 days. Has the infection died out entirely? Like it did. Remember, it didn't even get started when we changed it to half its value when we ran it up front. Has the infection died out? No. It also hasn't changed this in a very, very obvious way, this upper pattern. But we actually do see a much more regular pattern here. Okay, let's suppose we were to press that again. What's it going to change it from now? It's 5 now. It's going to change it to what? 2.5. Oh, look at that. What's happening? Why isn't this changing? Why isn't it moving up? Why was it moving up before? Almost like an upwards rain. What's that? Yeah, as they were going through life, we had this individual, each individual is getting affected more and more times, right? And so each of these purple dots was moving upwards, right? It was moving upwards like it was raining upwards. Do you remember that? In fact, maybe this is what that rock star was singing about when he had that song Purple Rain. Well, okay, maybe not. But I like to think that. Who are these folks down here at the bottom? Who are these folks down here at the bottom? As we're running this, what are we seeing? Who are these folks down here at the bottom? And why is this top getting less and less dense rain? Maybe you had a follow-on like purple ice. But these are new people being born. These ones aren't, ladies and gentlemen, developing more infections, but they are getting more connections. Why are they getting more connections? Because of births. It's getting a more and more dense population. I mean, take a look at that. Okay, ladies and gentlemen, so now we've essentially eliminated infection from the population through not by a factor of 2, but a factor of 4 will actually eliminate established infection. Mark my words, that initial, if we undertook, this is an important point. It's almost so important I'm tempted to get up on it. Ladies and gentlemen, when we undertook that intervention from the start, when we had halved the infection time, we had faster treatment, so we got people cured within 5 days instead of 5 days instead of 10. People, the infection died out almost immediately, but that wasn't the case when we let it be established. We lowered from 10 to 5, and it didn't kill the infection off. There was a lock-in effect, folks. There was a lock-in effect. Once it got established, it takes more effort, a lot more effort to deal with it, though. So a lot of things like this in life, heading off an addiction, by heading it off early is a lot easier than dealing with it later. Heading off a traumatic event requires perhaps less effort than dealing with picking up the pieces later in life of all the outcomes of that traumatic event. If you could prevent a case of child abuse, just imagine how much easier that is than trying to deal with its effects. There's a lot of cases in the world, ladies and gentlemen, that exhibit lock-in. It's a phenomenon of nonlinear systems. So these systems get in a situation where, it would have been much easier to prevent it from happening. Once it happens, it gets in one of these basins of attraction, and to get it back over the hump to a healthy state takes a lot more effort than if we had just nudged it up front, and it could have gotten over there. So ladies and gentlemen, this is a case where we have lock-in. It requires, whilst it's enough to reduce the infection time by a factor of 2 up front, we need a factor of 4 to achieve the same effect, it seems, later once the infection is established. This is quite common in these sort of models, okay? This button provides us a flexible way of trialing these things, and the name reflects a project that Winchell was working on, and later Wade, on pertussis vaccination, where we have an exceptionally engaged stakeholder. This is a stakeholder who's a deputy medical health officer in Alberta Health Services, and he's a medical doctor, infectious disease physician, but he's also a faculty member, and he's helped sponsor several modeling projects on our part involving childhood infectious diseases. And compared with any other stakeholder, with the exception of Cheryl, he's more involved. Cheryl and he are kind of at the same level. Both of them run the model, they'll tweak it sometimes, modify it, etc. But he's especially laser focused when he comes to visit, because he only has short times here. So he'll spend long times with us over a couple days in a very, very concentrated way. And he was fascinated by model results, and this was for an outbreak response intervention strategy. And so the idea is the model would note if an outbreak is occurring and then undertake an intervention. We'd see the effects of different rules, for example, for when to undertake that intervention. How would that affect the gains made from this? But we didn't have that logic in there yet at this point. And he was really keenly interested for how would an intervention affect an outbreak. But the logic wasn't there yet. It's been there for a long time now, but it just wasn't programmed up yet. We had to have an outbreak recognition tool. Some of Xiaoyan's work with machine learning actually could be fruitfully applied to improve the outbreak recognition tool for the Winchell model. So instead, he was saying, how could I do this? How could I investigate this? I said, well, worst case, we could give you a button to undertake the intervention. But I said, it's going to be brutal, because you're going to have to look at the model results, and then when an outbreak's occurring, you're going to have to press that button. But he said, yeah, build me the brutal button. And so we built him the brutal button. And then he went back to his hotel, and he said, I think he was up for like 5 hours that evening, like 2 a.m. or something, looking for this outbreak. Press it. Okay, now what happens? Oh, cool. He was running. He said he spent hours just just waiting for these interventions. Press the brutal button. Oh, it's too late that time. Okay, here comes another one. Boom. So ladies and gentlemen, that's the story of the brutal button. Brutal buttons are not, they're a somewhat blunt instrument for achieving experimentation, but they can be insightful, particularly about flexible timing and when you link it to certain events in the model. But we have to achieve, ladies and gentlemen, we have to achieve our more focused goals here, which is to undertake a target intervention. So I'd like to take you in a different direction, if I may. So I'm going to actually